Okay, we're talking about 7th grade exponents. And in case you didn't know, what I should tell you is this 4 is called a base. And the little baby 2, that's the exponent. And all together, we call this a power. And so that's really all you need to know. And now you need to just kind of follow your nose through stuff and use rules that you know about numbers and multiplication. Now, what this means, this 4 with the baby 2 up there for the exponent, means 4 times 4, which is 16. And students always make the mistake, they think it's 4 times 2, but it's not. It's 4 times 4. And I actually have another video that I'll link to in the corner. And I think this is actually 1 times this, but that's for another video. And you can check that out. So what's important here is we really dive in and think about what's happening here. That 2 says you want to repeat the base that many times. And that's what happens. 4 gets repeated 2 times and is dealing with multiplication. That's the operation. Now, this one right here is a little bit different, but some similar ideas. That 2 means whatever it's touching, you want to repeat it. So this is touching the parentheses, and the parentheses means, okay, everything inside the parentheses is getting repeated 2 times. So we're going to do what? That's going to be -4 times -4. And if you don't put anything in between the parentheses, that means you're multiplying. Now, if you've been through 7th grade math, you know that a negative times a negative is a positive. So -4 times -4 is a positive 16. And you'll notice here, you got the same answer. So if you have 4 times, if 4 to the second power is 16, and -4 to the second power is also 16. You might be wondering, well, what's up with the parentheses then? You don't even need it, right? You do, though. This is an important deal because the next one I have is seemingly the same thing. You have this 2. You got the 2 just like you have the other 2, and you have the -4 just like you have the other -4, but now we don't have the parentheses. And this is actually different. That 2 is touching the 4. Now, it's not touching the 4 and the negative. So what gets repeated is only the 4. So this ends up being 4 times 4, which is 16. But that negative, let me bring this up a little bit here. That negative right here gets shucked in there. So it's actually -16. And I could say that this here, that statement, the 2 and the 4, mean perhaps the square of 4. And by the way, we call it, when you have a little 2 for the exponent, we call that a square, because what we're saying is you're making a square. Let's say I'm making a square out of dots. And one side has 4, and the other side has 4. And then I'll fill in the rest of the square. And I have 16 dots in the entire square. That's why we call it 4 squared. It's talking about the area of a square where each side of the square has 4. Now, if that part of the statement says 4 squared, or 4 times 4, however you want to think of it, then this would mean the opposite of 4 squared. So I'll put this in blue. So this negative right here means the opposite of the square of 4. And if the square of 4, which I show up here, if the square this is the square of 4. If the square of 4, or 4 squared, is 16, then the opposite of the square of 4 is the opposite of 16, which is negative 16. That's what's going on with that whole thing. All right, so we have this. What might this be? So this would be, you got negative 3 times negative 3, which is positive 9. Nothing too sharp there. So this one over here, this is the opposite of 3 squared. So if we know that, if we look at this part here and we know that 3 squared is 9, then this means the opposite of 3 squared, which is negative 9. Okay, nothing too earth-shattering here, but I'd like to introduce these others here. Now, if we have this one here, so negative 3 to the third power, that would mean you have negative 3 times negative 3 times negative 3. And if you piece this together, we already know that this is 9 from here. We can borrow this here. We already know that's 9. 9 times negative 3, you hopefully know that 9 times 3 is 27. And from your work with integers, positive times negative is negative. So that's negative 27. Okay, so let's look at this here for a moment. Slow it down. Negative 3 to the second power is 9. Negative 3 to the second power, you actually read them the same way. Negative 3 to the second power is negative 9. The difference is you have parentheses here. It's positive. You don't have parentheses, it's negative. But check this out. I had parentheses here, and it was negative. I broke it down. This one's going to be 3 to the third power, so that's going to be 3 times 3 times 3, which is 27. But it's the opposite of 3 to the third power, so it's the opposite of 27, which is negative 27. And check it out. This is negative 27, and this is negative 27, while when we have them to the second power, that was positive 9, and that was negative 9. So sometimes they're the same answer, and sometimes they're different answers. And what it comes down to is the idea that when you have an even exponent, you have an even number of negatives being multiplied. And so that's going to be positive. But it doesn't matter how many exponents, what the exponent is here, it's always going to be negative. So the even numbered exponents are going to have different signs depending on where the parentheses are. But if you have an odd number of negatives, like this one, like 3, 1, 2, 3, if you have an odd number of negatives, you're going to end up with a negative number as your product. And here, you can just take 3 to the third, and then it's always going to be negative. So if you don't have the parentheses, it's always going to be negative. But if you do have the parentheses, you have to look at the exponent. And that is a main idea there. That idea will take you pretty far in the world of exponents. So, to review, you've got the basics of what does an exponent mean and the differences between having parentheses and not having parentheses, and what that means as far as when you're talking about higher numbered exponents. So I hope this has been helpful for you. Thanks for watching, and look for more math videos in the future. Bye.